Welcome back to the channel. This video is on the Colorado Plateau series and looking at the Grand Canyon, and in particular the Grand Canyon walls and the layers of different sedimentary rock, igneous rock and metamorphic rock, and how this amazing canyon has been sculpted by the river to expose about 1.6 billion years of geologic history. This is the Earth Science Classroom. We can thank the action of water and the Colorado River for its erosional power, as the Colorado Plateau in general was lifted up about 5 million years ago and allowed this amazing river to flow from its source in Colorado down and down cut through this amazing rock to create the canyon itself. At the Grand Canyon, when you look in either from the north rim or the south rim, and you look and see this beautiful layered rock on the canyon wall, you're looking at one set mostly, and in the inner gorge there are two other sets. But this video, we're going to look at each independent group or sequence of rocks in detail. The Grand Canyon has three main divisions of rocks, or sets of rocks. The first one is the basement rocks, which are the oldest. Then we have the second oldest, which is the Grand Canyon supergroup. And then we have the third and most recent and the youngest, which is the Paleozoic era sedimentary rock strata, which is the majority of the canyon wall when you look into the canyon itself. And the Paleozoic strata starts around 445 million years ago, and the Grand Canyon supergroup is between 745 million years to about 1.2 billion years, and the oldest is the basement rocks of around 1.6 to 1.8 years old. So let's start with the basement rocks. These rocks are the igneous and metamorphic. So the metamorphic rocks are the Vishnu schist and the gneiss, and the igneous rocks are the plutons, and one in particular is the Zoroaster granite. So this indicates that around 1.6 to 1.8 billion years ago, you had a metamorphic rock formed through heat and pressure deep down in the Earth's crust, and you have this through an orogenic belt formation of mountains, and you had an igneous activity and volcanism at that time with the igneous rock and the granite mostly going to be intrusive igneous and the plutons. So you had this Precambrian, early Proterozoic era rocks that form the basis and the bottom of the Colorado Plateau and also of the Grand Canyon. The next rock set in our summary of the Grand Canyon rock strata is a very large and important group, which is the Grand Canyon supergroup. It is a bunch of layered or sequence of layered sedimentary rocks that are tilted and angular, and they're divided into two different divisions, the Uinta group and the Chuar group. Now the Uinta group is the lower one and the older one, and the Chuar group is closer to the surface and more recent. Now this dates between 725 or 740 million years ago to the oldest about 1.25 billion. So there is an unconformity between the metamorphic basement rocks, the Vishnu schist and the gneiss, and the supergroup of around 500 million years of unconformity. Then we have an unconformity above the supergroup where there's a layer of erosion, and that separates the supergroup rocks to the Paleozoic sedimentary strata. That is about 200 million years, and that's part of the great unconformity, which I'll get to later on. Now this supergroup and the divisions, these layered sedimentary rocks, are mostly sandstone and mudstone, which represent a shallow sea based on the fossil record of this area of the Colorado Plateau being under a shallow sea at around 1 billion years ago. And then after they were formed, there was an orogeny. There was a period of time where these rocks were forced together by compressional forces, tectonic forces, and they were forced to be changed angle and become tilted. So there is an angular unconformity at the top of this supergroup that divides the supergroup to the Paleozoic era rocks. The final set for the Grand Canyon is the Paleozoic era rocks, which is part of the Phanerozoic eon. So we're now moving into the most recent eon and the Paleozoic era, which goes from about 545 million years to around 255 million years ago. So you have a period of geologic time spanning about 200 million years where the canyon wall was built layer upon layer over the course of that 200 million years, and it stopped around 255 million years ago, which represents the Colorado Plateau surface, or where you would look into the canyon from the north or south rim. So we'll start at the bottom. The bottom layer is what's called the Tonto group. It is a unit of sedimentary rocks that are split into 3 layers, 3 strata. The bottom one is the Tapeats sandstone, the Bright Angel shale in the middle, and then a thin layer of Moab limestone at the top. So these sedimentary rocks represent a period in the Grand Canyon's history, or the plateau's history, whereby there was still that aspect of water and a shallow sea or an ocean or a continental shelf, where both the limestone and the shale and the sandstone all formed in this amount. And you can also, based on the thickness, see how long each period of rock formation occurred, and then from there figure out how long each environment lasted for before it changed, and therefore changed the sediment and then changed the accumulating sedimentary rock. And the Tonto group is mostly in the Cambrian period, and the Moab limestone kind of dips into the Devonian period, which dates to around 419 million years ago. Now, above the Tonto group is a layer of unconformity, a disconformity, which means there's 2 sedimentary rock layers either side, and this represents missing time of erosion. Then we have the red wall limestone. Now, this represents a shallow sea. It is 500 feet thick layer and starts around 340 million years to about 320 million years. So about 20 million years, a shallow sea was in this area and forming and depositing the limestone. Then we got a period of uplift, another disconformity on the top of the red wall limestone. And then the next is the Supai group. The Supai group is a mixture of 4 layers dating between 275 million years ago and 320 million years ago. And this includes both red sandstones, siltstones, shales, some jasper, which is some red shirt, and some limestone. It's about 1,000 feet thick. Now, this Supai group represents a period of another time of river deposits, probably coastal area, shallow seas, again, where the drop and rise of the sea level represents the change in the rock types. And the presence of the iron oxide gives the red appearance, and this also denotes the climate and the amount of oxygen and the amount of time the rock was above sea level. Next is the Hermit Shale, which is weirdly named because it's not actually shale. It's a combination of siltstone, which is more red, and sandstone. This comes from flooding. Now we have the Coconino Sandstone, which is now in the Permian period, which dates between 299 to 251 million years ago. Next is the Tucoweep Formation, which is a combination of gypsum, shale, and sandstone. So you have gypsum being an evaporite, where you have evaporation leaving the salts to condense on the surface. So you could have a very large lake that's dried up or being pushed up. You might have the shale and sandstone being formed through river deposits, alluvium, or some sort of delta, and this gives an idea of the kind of environment you had at this time. And last but not least, the Kaibab Formation, which is a large extent of the Colorado Plateau, and in this case for the Grand Canyon represents the top layer of rock which you would stand on if you're looking into the canyon itself from the north or south rim. So it is a combination of limestone and siltstone, which again tells you that at that time in geologic time and history, there was still a lot of water present in the Arizona area based on tectonics and movement of the North American continent. And this was right before Pangaea started to break up. So about 50 million years before Pangaea broke up. So you still had that supercontinent like we had with Rodinia at 750 million years ago. And beyond this, from 255 million years to the present day, there has been uplift, and we know from the last 5 million years there has been extensive uplift of 4,000 to 6,000 feet of the whole Colorado Plateau, and this has created a lack of deposition, a period of unconformity, we're missing time, where there is just weather and erosion, and this weather and erosion has created the Grand Canyon through the river and also created many of the national parks on and around the Colorado Plateau, which are absolutely spectacular, all down to wind and water, time and weather and erosion. So as an overview, the Grand Canyon's rock strata or rock layers are fascinating because you have this basement rock of orogenies and metamorphic and igneous suites overlain by over 1 billion years of sedimentary strata that represent and reconstruct different environments that have occurred over this period in this location as the whole North American continent has moved through convection currents and plate tectonics across the Earth's surface. Now, the abundance of layers and strata of not only limestone, shale, and sandstone all throughout the billion years, ranging from the Kaibab Formation at the plateau surface all the way down to the unconformity between the supergroup and the basement metamorphic schist and gneiss of 500 million years, this great unconformity. It's telling you a story of what happened in this area, and what's happened is you have an abundance of shallow seas, deeper oceans, coastal regions, river sediments, forming these different types of sedimentary rock throughout the billion years of this location's history, arriving at 255 million years ago, where the uplift happened and no more deposition occurred. But you have this beautiful history book shown by the different layers and strata of sedimentary rock and how these rocks form in certain depositional environments. And we can reconstruct this all the way back to 1.8 billion years down to the inner gorge and the basement rocks. This is the Earth Science Classroom. Thanks for watching the video. If you liked it, please subscribe, like, and share. And if you want more content and videos on Earth Science, please check out my channel.